Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using variation of parameters method. So let's get going. Problem: solve y double dash plus n square y equal to secant n x or d square y by dx square plus n square y equal to secant n x or d square plus n square into y equal to secant n x using variation of parameters method. We are given a differential equation of order 2, right? Given differential equation y double dash plus n square y equal to secant n x, considered as equation 1. Or we can write y double dash as d square y by dx square plus n square y equal to secant nx, or we can write d square y by dx square as capital D square y using the differential operator capital D. Now take y common from the terms. In LHS we'll get d square plus n square into y equal to secant nx, considered as equation 2. See, the first equation and the second equation in operator form is our third equation. Say f of d into y equal to some function of x, right? Where f of d is d square plus n square and function of x, that is r of x, is secant nx. Let's now write the homogeneous equation of equation 2. The homogeneous equation of 2 is d square plus n square into y equal to 0, considered as equation number 3. Right? Now we'll find the solution to the homogeneous equation using the auxiliary equation, and later using the solution of homogeneous equation we'll find the general solution of the given equations just by changing the parameters. Okay? Now coming to the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square plus n square, right? Let's replace the differential operator d by m, so that we'll get f of m equal to m square plus n square. Then the auxiliary equation becomes m square plus n square equals to 0. Let's find roots to this equation just by taking the second term to RHS. We'll get m equal to plus or minus square root of minus n square, and we can write minus n square as minus 1 into n square and split the square root. A square root of minus 1 into square root of n square, which is equals to plus or minus I into n, since square root of minus 1 is I and square root of n square is n, right? Therefore m equal to plus or minus I n. The roots are complex conjugate. We know that when two roots are complex conjugate, or we have a pair of complex conjugate roots, say a plus or minus ib, then the solution to homogeneous equation looks like y equal to e power ax into c3 cos bx plus c4 sin bx. In case of a0, we'll have e power 0 into x, which is e power 0 into c3 cos bx plus c4 sin bx, right? Let e power 0, since e power 0 is 1, right? So this becomes c3 It is 1 into C3 cos bx plus C4 sin bx, right? Which gives us y equal to C3 cos bx plus C4 sin bx. Let's now write the solution to our homogeneous equation, equation 3. The solution to homogeneous equation is y equal to C3. Just compare plus or minus in with plus or minus b. Then for b equal to n, we'll have C3 cos nx plus C4 sin nx. Therefore, y equal to C3 cos nx plus C4 sin nx is the solution to equation 3. We are taken C3, C4 instead of C1 and C2 because we want C1 and C2 to appear in the last general solution to our problem. Okay. Let y equal to, just replace the constants or parameters with some functions of x. A and b will get y equal to a cos nx plus b sin nx. B, the general solution of the given equations. Where a and b are functions of x. Now we can compare the solution to homogeneous equation with y equal to some C3u plus C4v, or the general solution with y equal to au plus bv, so that we'll get u and v, where u is cos nx and v is sin nx, or u is cos nx, v is sin nx. Here we'll find a dash and b dash using a formula. A dash is given by minus v into r of x by uv1 minus vu1, and b dash is given by u into r of x by uv1 minus vu1. If you notice, we are having uv1 minus vu1 in both the formulas, so we'll begin with uv1 minus vu1 and later we'll find a dash a, b dash b. Finally, we'll put ab in y equal to a cos nx plus b sin nx to find the general solution to our problem, right? Now coming to uv1 minus vu1. v1 is nothing but v dash minus v into u1 is nothing but u dash. This equals to u cos nx into v dash sin nx dash minus sin nx into u dash cos nx dash. It gives us cos nx into derivative of sin nx with respect to x is n cos nx minus sin nx into derivative of cos nx with respect to x is minus n sin nx, which gives us n into cos nx cos square nx minus into minus plus n into sin nx is sin square nx, or we can write it as n sin square nx plus n cos square nx. Now take n common from these two terms, we'll get n times sin square nx plus cos square nx. Since we know that sin square theta plus cos square theta equal to 1, so we'll get sin square, or we can replace sin square nx plus cos square nx with 1. We'll get n into 1 is n. Therefore, uv1 minus v1 equal to n. Now coming to a dash. A dash is given by minus v into r of x by uv1 minus vu1. V is sin nx into r of x is secant nx by uv1 minus v1 is n. This gives us minus 1 by n into sin nx secant nx. Since we know that secant theta is reciprocal of cos theta, or secant theta can be written as reciprocal of cos theta, so we'll replace secant nx with reciprocal of cos nx for our convenience. Is equals to minus 1 by n into sin nx into 1 by cos nx is sin nx by cos x, which is tan nx, right? Therefore a dash equals to minus 1 by n tan nx. Let's now find a using this a dash. We have a dash equals to minus 1 by n tan nx, right? A dash is nothing but derivative of a with respect to x. Just separate the variables by taking the differential dx to RHS. We'll get dA equal to minus 1 by n tan nx dx. Now here the variables are separable, so we can perform integration. Integral dA equal to minus 1 by n integral tan nx dx. Since we know that integral tan a theta d theta equal to minus 1 by a log mod cos a theta, or 1 by a log mod secant a theta. Okay, this gives us a equal to minus 1 by n. For a equal to n, we'll have, I'm going to use the first one. We'll get, if I use the first one, we'll get minus 1 by n log mod cos nx plus some integral constant, say c1, or if I use the second one, I'll get minus 1 by n into 1 by, for a equal to n, will have 1 by n log mod secant nx plus some integral constant, say c1. This gives us a equal to minus into minus plus 1 by n into n square log of cos nx plus c1, or minus 1 by n into n square log of secant nx plus integral constant c1. Therefore a equal to 1 by n square log of cos nx plus c1, or minus 1 by n square log of secant nx plus c1. So we got a, and let's now find b dash and b. B dash is given by u into r of x by uv1 minus v1 is equals to u cos nx into v secant nx by uv1 minus v1 is n, which gives us 1 by n cos nx into secant nx. Since we know that secant theta is reciprocal of cos theta, so let's replace secant nx with reciprocal of cos x, that is cos nx. What I mean is, now cancel cos nx, will get 1 by n. Therefore b dash is 1 by n. Let's now find b using this b dash. We have b dash equals to 1 by n, right? B dash is nothing but derivative of b with respect to x. Now let's separate the variables by taking differential dx to RHS. We'll get db equal to 1 by n dx. Here the variables are separable. So let's perform integration. This gives us b equal to 1 by n integral dx is x plus integral constant say sum c2. Therefore, b equal to 1 by n x plus c2. We got b and a. Let's now find the general solution using y equal to a cos nx plus b sin nx. Therefore, the general solution is given by y equal to a cos nx plus b sin nx. Then we'll get, if you use the first a, we'll have 1 by n square log of cos nx plus c1 into cos nx plus b x by n plus c2 into sin nx, or if you use the second one, you'll have minus 1 by n square log of secant nx plus c1 into cos nx plus b x by n plus c2 into sin nx, right, which gives us 1 by n square cos nx log of cos nx plus c1 cos nx plus 1 by n x sin nx plus c2 sin nx, or minus 1 by n square cos nx into log of secant nx plus c1 cos nx plus 1 by n x sin nx plus c2 sin nx. Or we can write it as y equal to, write the terms involving c1 and c2. Firstly, we'll have c1 cos nx plus c2 sin nx plus the remaining terms 1 by n square cos nx log of cos nx plus 1 by n x sin nx, or write the terms involving c1 and c2. c1 cos nx plus c2 sin nx. Now write the terms, the remaining terms, minus 1 by n square cos nx log of secant nx plus 1 by n x sin nx. This completes the problem. So we have seen a problem from variation of parameters method in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.